Prynhawn da pawb, good afternoon everybody and welcome to this e-sgol catch-up session for AS Geography. I will now hand you over to Miss Davis, who is delivering today's lessons covering the topic of coasts. Diolch.
Prynhawn da, good afternoon. My name is Miss Taylor Davis and welcome to the first session of the Cwrs Carlan catch-up sessions for AS Geography. Today's session is focusing on Unit 1 coasts. Now, it is up to each school if pupils study coasts or glacial landscapes. If you studied glacial landscapes, you will not need to learn about coastal landscapes. So what is the latest situation regarding the exams? Well, as you're aware, in 2021, there will be no exams in AS Geography. Your teachers will determine your grade. Your teachers will use a variety of evidence when determining your grade. You will need to develop skills in order to successfully answer geographical questions, and you must ensure detail and depth in your answers. But remember, it is at the discretion of your centre, your school, on what work is being assessed and being used to determine your grade. In today's session, we will focus on the following topics. 1.1.1, the operation of the coast as a system. 1.1.4, factors affecting coastal processes and landforms. And 1.1.5, processes of coastal weathering, mass movement and erosion. I would have liked to cover a lot more than that, but in 40 minutes that's impossible, so I'm going to look at those 3 units well. So first up is looking at 1.1.1, the operation of the coast as a system. So what is a system? Well, to put it simply, the coastal system is a series of inputs, processes and outputs. The coastal system is the transfer of energy and materials through inputs, processes and outputs. Here we have on the screen now is a table with the inputs, processes and transfer and outputs all on one slide. The inputs to the system, which inputs energy to the system, are marine, so waves, tides and currents. Energy that comes from the kinetic energy from waves and wind, and energy from the sun. Geological, so we've got rock type, structure and material from marine deposition, weathering and mass movement. We have atmospheric inputs such as climate, weather and climate change. People, because the activities of the humans can impact the inputs of a system, and people can input groins, for example, which then has a knock-on effect on the whole system. Processes or transfer, the most common one being Longshore Drift, which is the transfer of sediment along a beach. And processes also include erosion, weathering and mass movements. And throughout this presentation, we'll go over all those things. Output in the systems can include the landforms, which you have at the end. For example, landforms of erosion include the cracks, caves, stacks, stumps. They can include wave-cut platforms and blowholes. You can also have landforms of deposition, which are beaches, spits, tombolos, sand dunes and salt marshes. All the things that you see on the screen now all interact together and they all operate as a system. You can also split the coastline system into 2 subsystems, which is the beach subsystem and the cliff subsystem. Now, the cliff subsystem has inputs of sub-aerial processes of weathering and atmospheric process of wind erosion, the transfer of cliff mass, movement of falls, slips and slumps, and the output of sediment at the base of the cliff, which is either deposited or is transported by marine processes. These are all things we'll cover in detail further on in this presentation. The beach subsystem has an input of sediment from Longshore Drift. The cliff and offshore are also inputs of sediment. If cliff is eroded, well, that sediment input into the beach subsystem. It is transferred in the subsystem by Longshore Drift, and then the output is the beach as a landform. Okay. Now, here we have a sediment cell. I want you to study this picture on the screen carefully. I want you to consider this. Where has the sediment come from and how has it arrived here? Where is sediment stored in the system? And how does sediment leave the system? So, a sediment budget means is knowing exactly how much sediment is coming into the system, which is input, and knowing how much sediment is leaving the system, which is output. Okay, now, coming back to this picture, where has the sediment come from? Where is it stored in the system? And how does it leave the system? Okay, so in order to cover that, I wanted to show you this slide. So there are three main sources of sediment. These are rivers. So material eroded along the river is then deposited in the coast, in mouth of the river. Cliffs being eroded is a source of sediment. And sand dunes, to an extent, is a source of sediment. So these are the three main sources of sediment. Of these, rivers are thought to be the most important. Cliff and dune erosion can also input large amounts of sediment and are important locally. Sediments are also transported onshore by waves and currents from sandbanks in the offshore zone in the sea. These sandbanks are important sediment sinks, and I'll go on to talk about sinks in a while. Which source of sediment is most important usually depends on the characteristic of the local area. For example, if the coastline is dominated by soft, chalky cliffs, then cliffs will be the most important source of sediment. But in some areas of the world, it is a river, for example, in Bangladesh. Or if we are in Mississippi and you have the Mississippi Delta, well, all that sediment from the river has been deposited there, creating new land. And here we have an image of that here. A river with a high sediment load, and over time the accumulation of sediment has created a new delta, new land. In this diagram, we have a typical sediment cell, which has inputs, processes, and outputs. Now, an example of an input here is a sand source, okay? For example, rivers, cliffs, and sand dunes. Where you have a sand sink, these are outputs. Sinks are location where the dominant process is deposition and depositional landforms are created. So when the sediment is being stored or put into a landform. So some examples of sinks are sand dunes, which are in the back shore of the beach, or beaches, which are in the foreshore of the beach. Those are examples of sand sinks where sediment is being stored. You also have a transfer from the sand source to the sand sink. Okay, these include Longshore Drift and the swash and the backswash of the waves. And we'll go on to talk about them in a while. Here we have on the screen now are sediment cells, and there are 11 sediment cells in the whole of England and Wales together. Sediment cells are called a dynamic system. They are dynamic because the sediment is constantly generated in the source region, for example, cliffs or rivers, transported through the transfer region, for example, Longshore Drift and waves, and deposited in the sink region, for example, a beach. Okay, and on the screen here says the sediment cell concept, which is source, transfer and sinks, is important in understanding the coast as a system. With both positive and negative feedback, it is an example of a dynamic equilibrium. So what is a dynamic equilibrium? Dynamic equilibrium is reached when inputs of sediment from the source region are balanced by the amount being deposited in sinks. It's in balance. It's dynamic though, because although it's in balance, there's constant movement of sediment through the system. So if the input and outputs within the coastal systems are the same, then a state of equilibrium has been formed. Okay, this is an example. Okay, an example would be that the rate of sediment being added to a beach is the same as the amount leaving the beach, resulting in the beach remaining the same size. If something happens to break this equilibrium, the system will change to restore itself. This is known as dynamic equilibrium, as a system can respond to disturbance. So there are four main factors needed to be in balance for dynamic equilibrium to be achieved. You have sediment supply, so we need a constant source of sediment supply, wave energy, sea level, and location of the shoreline. Before I go on to talk about beaches, I just wanted to go over this again, because an equilibrium is a specialized geographical concept. And if you in exam answers talk about equilibrium and you understand the concept, same as a system is a concept, it's very skilled and it shows application of knowledge. Okay, right. You have here a picture of a beach. Beaches are dynamic features. What you'll be familiar with is how sediment is transported within the system. The main transport method is longshore drift. We have a diagram of longshore drift. So at the bottom there, you see the arrow which shows the prevailing wind, the most common wind direction. The swash approaches the coast at an angle because of the direction of the prevailing wind. So you can see here, the swash approaches the coast at the same angle as the wind. The swash will carry this material along the beach at an angle. The backwash then flows back to the sea, but on a 90-degree angle due to gravity. This process repeats itself along the coast in a zigzag movement. So here now, the sediment would go to the right direction because of the direction of the prevailing wind. Now, here we have a popular method to protect our beaches and to stop erosion and cliff retreat, which is groins. And here we have a picture of wooden groins. Why build groins? Well, groins prevent longshore drift from transporting the sediment or sand away from that particular location. Because remember, a beach is important for numerous reasons. One, the local area and the local economy may depend on that beach. For example, it could be a tourist area. But also, a wide beach means that the waves have to travel along that beach and the wave energy will decrease by the time it reaches the coast and where you have housing there, which means there won't be any erosion. So a wide beach is an important method on slowing down coastal erosion. But groins, which that's human interference there, groins can impact the equilibrium of the sediment cell because the groins reduce or halt the sediment supply to the sink region. So groins only benefit the area directly where there are groins, directly where it stops longshore drift. But it does mean it hinders the supply of sand further along the coast, which will only increase the rate of erosion. Okay, so shortly after a groin is put into place, a section of cliff immediately downdrift of this work begins to erode at an increased rate, often dramatically. That means the equilibrium further down is not in balance. Okay, this balance has been upset by events such as the groin being put into place, and that means it will be further eroded down the line. Now, here we have an interesting question that will need application of knowledge. What can happen to depositional features along a coastline, for example, a beach, if human activity decreases the supply of sediment from longshore drift, for example, by installing groins? Well, here we have the answer. The equilibrium will adapt to the decrease in its input to reach dynamic equilibrium. As less sediment is deposited due to human activity, for example, groins, perhaps erosional activity will have more of an impact, which will decrease the size of the depositional landform, for example, beach. This eroded material could be transported further along the coast by longshore drift. Okay. An important geographical concept in geography as well is the concept of feedback within the coastal system. A positive feedback is not necessarily a good thing. I don't want you to connect positive with happy and great things, okay? Here in the feedback system, feedback concept, a positive feedback happens when the change produces an effect that operates to increase the original change, like a knock-on effect. When one change leads to another change, leads to another change, and that means there won't be equilibrium. Here are some examples. When wind erosion of a dune section during high velocity storms may remove stabilizing vegetation. Okay, that's happened. The knock-on effect of that will mean this. Further wind erosion now occurs in later low velocity wind conditions where they wouldn't have been usually, increasing the depletion of dune sand. So what disrupted the equilibrium there was extreme wind, maybe from a storm, which affected the equilibrium. There's now no equilibrium there. That's positive feedback. So the storm meant it blew away the vegetation that was stabilizing the sand dunes. Now there's no vegetation there. Even when there isn't a storm, now more erosion takes place, which will affect the sand dune even further. So I don't necessarily want you to connect positive feedback to happy changes. Okay, it's usually just changes have been exaggerated by another change, which has a knock-on effect. You also have negative feedback. Here we have the change produced creates effects that operate to reduce or work against the original change. For example, when erosion leads to blockfall, that's rockfall, mass movement, the collapsed debris acts as a barrier protecting the cliff base. Now that you have a barrier at the bottom of the cliff base, that then will absorb the wave's energy and will slow down erosion. So that means it's gone back into balance. Okay. Another example is major erosion of sand dunes could lead to excessive deposition offshore, like an offshore bar, that reduces energy because the waves now will break further out to sea near the offshore bar, allowing the dunes time to recover. So we're back in equilibrium. So that's negative feedback. Please use concepts such as equilibrium and system and feedback when writing your answers, because they're highly skilled, specialized geographical concept. If you're unsure how to use them effectively, please ask your teacher. This is something that you'd want to use in all your geography units, not just this one. And that's us, in a nutshell, have covered 1.1.1, the operation of a coast as a system. Now we're going to move on to 1.1.4, which is factors affecting coastal processes. I'm also going to integrate a lot of 1.1.5 here, which is mass movement, weathering and erosional processes. I don't have time to look at landforms today, but I'm going to bring in the processes and movement. Okay. Waves play an important role in the coastline. So waves are generated by wind blowing over the sea. The characteristics of waves are determined by the strength of the wind, so wind speed, its duration and fetch, which is the distance a wave travels, the wind blows on the sea and the distance a wave travels, and orientation of the coastline. So the stronger the wind, the greater the friction on the surface of the sea, and therefore the bigger the wave. Now there are two main types, destructive and constructive. Now, destructive, as you see at the top there, has a higher wave height, and you see these usually during the winter. Here, the swash energy is less than the backwash. Because the backwash is stronger, that means it strips the sediment away from the sea, removes the sediment from the sea. On the other hand, the constructive waves have a weaker backwash in comparison to its swash. That means it's constructing and building up the sediment on the sea, on the sand, sorry, the beach, and forming a wide and sloping beach, more gradual beach. Here we have wave refraction. Wave refraction involves waves breaking onto an irregularly shaped coastline. So that's topography, like a shape of the coastline topography. So here we have an irregularly shaped topography. We have a headland sticking out here, and then you have two bays on either side. So here, the energy will hit into the headland first, and the headland, and the headland will absorb most of the wave's energy. By the time it goes into the bay, the low energy wave then spills into the bay, as most of the wave energy is concentrated on the headland. Because it's low energy in the bay, it leads to deposition. Okay. One of the main reasons as well you have wave refractions is if you have a shallow seabed. So if you have a shallow seabed, there's friction with the seabed as waves approaches the shore, causing the wave front to become refracted. So if the sea is shallow, the waves won't have the energy and will slow down and become weaker, also leading to wave refraction. That's it. Here we have lithology. Lithology is an important term. So lithology means bedrock lithology, igneous, sedimentary and metamorphic, and unconsolidated material geology are important in understanding rates of coastal recession. Okay, so how lithology affects resistance, right? That's an important word in this section, the resistance or the resilience of a rock. So a rock has a mineral composition. So some rocks contain reactive minerals easily broken down by chemical weathering, for example, limestone. You can also have geology, which is metamorphic, sedimentary and igneous rock, and structure. I'm going to go into the latter two in detail now. Here we have types of rock, which is geology. And this table is a good one if you can screenshot it or something, is the rates of erosion for different rock types. So at the top here on the left, we have igneous, and examples include granite, basalt, most common ones, and these have very slow rates of erosion. That's because they have interlocking crystals, which makes it resistant to erosion. They also have very few joints, so there are limited weaknesses that erosion can exploit. Then we have metamorphic. Now, metamorphic is also hard rock, but not as hard as igneous. Okay, so it's also quite crystalline, but metamorphic has usually been folded and bended during tectonic processes, so it does have more folds in the rock, and it's quite heavily fractured, which are weaknesses that can be eroded by the sea. And slate and marble are examples there. And then the softest rock is sedimentary, which erodes on a rate of moderate to fast, and sandstone, and limestone and shale are example here. So most sedimentary rocks are clastic. They are kind of a mashup of different types of rock, all mashed up together. So they have a lot of bedding planes and fractures, which are vulnerable to erosion. They're also quite weaker, so they are softer. We are now going to look at the structure of the rock. So the way that the rock has been organized. Okay. So here we have the strata. Now, if I refer to a strata of a rock, it means the layers, so layers of the rock, okay? The way, the direction. So here we have horizontal layers. Folds mean that the rocks have crumpled, usually back thousands of years ago due to tectonic activity. So we have here folds, which you can see the strata has crumpled. Here we have bedding planes. So bedding planes are formed when there might be a gap between the formation of the two types of rock, or if a top rock is placed on maybe a lower bed, which is a permanent, quite impermeable. We have joints, vertical, faults. Dip is angle of the rock strata, and this is important in determining what kind of cliff you have and what kind of mass movement you have. So here we have horizontal dip. So can you see the strata is horizontally here? Can you see that? This often leads to rock fall because bottom of the cliff gets eroded, forming a wave cut notch. Top of it gets unstable and crumples into the sea as big boulders. Here we have a seaward dip at a high angle. Here we have the most resistant cliff to landslides and mass movement because it's facing away from the sea, so gravity is pulling it back. Okay. I just want to quickly go over this before going on to weathering and mass movement. We have hydraulic oxygen, abrasion, attrition, and corrosion. So due to time, I'm not going to go through these now because these are one of the first lessons that you did in year 10. So I'm not going to go over it now, but you will need to know and remember these. So go back onto your notes and use the marine erosional processes. But in addition to marine processes, you have subaerial processes, okay? So looking at the picture at the right here, subaerial processes are land-based processes which alter the shape of the coastline. These are a combination of weathering and mass movement, okay? They're a combination of weathering and mass movement. So weathering is a gradual breakdown of rock in situ, there and then, or close to the ground surface. It can be divided into 3 types, and I'll go through that quickly now. And you also have mass movement, which is the movement of weathered material downslope. So the main question my students ask me is, what is the difference between erosion and weathering? Well, they both involve the breakdown of rocks and minerals, but erosion is the process in which material is moved. So with erosion, either the sea or the river takes away the material that's been eroded, but weathering, nothing moves it. It stays there and there in situ. Okay, so I don't have time to go through all these now, but a physical example of weathering is freeze thaw. You also have salt weathering, where you've got seawater being sprayed onto rocks and it leaves salt crystal behind, and these exert stress on the rock. You have wetting and drying, where porous rock will absorb water and expand, and then it will dry itself out, and then this wetting and drying will cause cracks. That happens in shale. Here chemical weathering. We have carbonation, happens to limestone, hydrolysis and oxidation. It usually happens to sedimentary soft rock like sandstone and limestone. I won't go through it now. And we also have biological weathering, for example, plant roots opening cracks in the rock, or animals that burrow. Right, mass movement. So mass movement, like I said previously, is the downslope movement of material under the force of gravity. It is an umbrella term for landslide, rotational slumping, and block fall, which is rock fall, and you've also got soil creep. So the types of mass movements vary, okay? It depends on lithology. For example, unconsolidated material means you have slumping. Or if you have consolidated rock, for example, limestone and granite, usually get more of a slide. So here we have a rock fall. These occur on slopes which have more than 40-degree angle, where rock fragment breaks away and either drops vertically or bounces down slow. So look at the structure now. There's quite, blocky. They still have rocks there. And like I said previously, these usually happen when you've got strata going horizontally. And usually you've got maybe a wave cut notch and perhaps the top will fall as rockfall. We also have rotational slumping, and this involves rock failure and movement along a curved rock plane. So this happens a lot slower than a rockfall. So rockfall will happen where you have a cliff with many joints, faults or bedding planes, okay, and it's very rapid. And then this happens when you have, it's basically facilitated by the presence of water, which adds weight. So because when the soil at the top on some rocks absorb water, it gets heavier, increasing weight, increasing the gravitational force and lubricating it, causing reducing friction, and it slides down a curved surface. You can also have a landslide, which is a mode of mass movement, and here you can see there's no structure to the rocks that's been weathered and slid down the landslide. Okay. And this usually happens down a quite flat or linear slip plane. Right, here's a good question that you may have, which is assess the importance of lithology on the rates of coastal retreat. I'm going to rush through this now because, right, this is an 8 marker. When you have an 8 marker, you will have 5 marks for your knowledge, but there will be 3 marks reserved for the assessing. Okay, so here I have quickly a bit of a mark scheme. So the question is, assess the importance of lithology on the rates of coastal retreat. So coastal retreat means coastal erosion. So to get the AO1, the 5 marks, you will need to talk about the types of rocks and their characteristics for igneous, metamorphic, sedimentary. You can talk about igneous has got interlocking crystals, which makes it resistant to erosion. Sedimentary has faults and cracks, is younger, clastic, okay, and name rocks. Chemical structure, if something gets weathered. Structure of the rock, for example, bedding planes, faults and strata. Or orientation of the rock. So if you've got concordant versus discordant coastline, I won't have time to look at that today, but that often influence the rate of erosion. If you've got headlands or bay, when you've got discordant, or if you've got concordant, you've got a bay. Okay. A cove, that's it, right. And then to get the SS, you need this 3 marks. You need to look, no, actually, not only does lithology affect on weather, coastal retreat, there's other factors as well. For example, types of rocks. Weather. Sorry, I think the first one needs to say types of waves. So my mistake, types of waves, so destructive or constructive. Weather, because the weather impacts the waves. Okay, the weather means it won't be in equilibrium. The geographical location, for example, the road of fetch and the tidal range. So the bigger the tidal range, the bigger the erosion rates. So this is what you need to include in that question, because it says, assess the importance of lithology on the rates of coastal retreat. So say, yes, these are the lithology and how they impact coastal retreat. But to assess, you need to say, it's not only lithology, but also these factors, so types of waves, weather, location. When you're looking at terminology, you need to use wording such as which factor is most important. For example, in my opinion, the factor that's most important is weather, because the weather will determine the type of wave, and you could go on like that. Or is factor X or Y significant or insignificant? That's the type of top terminology you need to use when assessing. Right, top tips to finish off. Please know your command words. There are some of them there on the right, but look at the questions that you have in an exam, and you need to understand the requirements of each command word in order to hit the full marks. Speak like a geographer. Use the key terms. Talk in detail and depth. Remember, you're AS geography students. You're not year 10 pupils anymore. You need to speak like a geographer. And remember to use a specialised geographical concept. Ask your teacher if you're unsure, if you don't have a list. But in this now, we've gone over the concept of a system, the concept of an equilibrium, and the concept of a feedback. Well, thank you. Diolch yn fawr I chi gyd. Thank you for tuning in. Next session will be a week today, and we'll be looking at Unit 2, Changing Places. Hwyl fawr, diolch.